Hello, my dear students. After a long time, welcome back to Resultant. So, very good evening, all of you. I hope everything is good, fine, perfect, and everyone is practicing for this upcoming exam. Okay, because already GATE examination happened, you got the result. Now it's the next step. Whatever mistakes you did in GATE examination, now it's a very golden opportunity for you guys to overcome that mistake. Okay, fine. So before starting the session, I hope so everything is good with audio and video, no problem, because we are meeting after a long time, right? So let me share this. Yeah. Okay, very good evening. All right. So today we're gonna practice some questions from theory of machine, because as you know that date has not been announced. We'll be daily practicing some minimum number of questions so that your practice is there. It's continuing for the examination perspective. Hello Prasant, good evening, good evening. Okay, fine. So let's begin. So before starting, I hope so everything is good and everyone is perfectly fine. Now let me show you. Okay, so once again, I welcome you back to this very beautiful platform, the student friendly, faculty driven platform that is Resultant, right? I hope so everything is fine. You know about this. So you can do connect with me on my Telegram channel also, those who are new to this session, and make sure you are subscribed to this particular channel so that you will be getting the latest update about all the examination. This is the current schedule that you will be following on YouTube. Okay, these are the YouTube session, right? So today we're gonna take a question from theory of machine. Then on 6th you will be Vikas sir is gonna take session on fluid mechanics. Okay, then Dheeraj sir on strength of material. Then again we'll be taking on 10th. Then thermodynamics and production. This is only till 14th. Okay, after that we'll be having the next set of schedule, right? Instead of giving a 1 month, because if I'm trying to design a 1 month schedule, definitely it won't be visible on this particular slide. Okay, so after every 2 weeks, again the next schedule will be floating and you will be having a continuity in the practice session, right? So every week we'll be having 3 sessions so that you'll be getting a very we can say a continuity in your preparation. Okay, fine. So this is all about this YouTube session. Please make sure you are taking the screenshot so that you will be joining. Okay, I'll be taking at 7 o'clock. All the classes that I'll be taking will be 7 p.m. Vikas sir might be taking a different timing, but I will be taking at 7 o'clock. Okay, now before starting the session, now let me I'm very happy to announce that we have launched a practice course for ISRO, because 160 number of seats, definitely that number is a huge one. Okay, this will be only for exam oriented. Okay, practice session only exam oriented. It won't be having like if I say Udaan course will be only having practice course for ISRO 2025. Okay, fine. And that too very nominal fees. You can do check on our app also. Udaan will be only practice course, no we can say theory or concept or revision. Okay, this will be purely for those students those who have completed their subject, completed their uh, we can say revision. They are only looking for practice session. Definitely this course is for them. And if I say Udaan Pro will be having a revision, okay, it will be having a revision of the particular subject along with that practice session. Okay, so definitely if you are looking for revision plus practice, so this could be a better option, right, rather than the previous one. But if you have done with the revision, now you're just only looking for practice, definitely you have to go with this Udaan course. Okay, so there are two courses now live, and you can do download our app on our Play Store, where you can get the resultant mechanical. Okay, you have to download resultant mechanical engineering. There you will be getting the access to these particular courses. Okay, fine. So now let's begin with some practice session of today's subject, one of my favorite, that is theory of machine. Okay, we'll be starting the practice session, and the question will be purely based on ISRO level. Okay, question will be purely based on ISRO level, right? And ISRO level is not that high. If I say from term perspective, it's not that high. Very easy straight away question, a very scoring from ISRO perspective. Term will be very scoring. Okay, so shall we begin? Yes, it will be approximately 30 minutes session, 30-35 minutes. So we have to cover some set of questions. That too, I'm again repeating, ISRO level session. Okay, ISRO level practice will be there, because definitely if you're preparing for GATE examination, the concept will be same, but the level of question that you have to practice will be slightly different. Okay, if you're preparing for ESE prelims, definitely the level of question will be slightly different. So every exam demand some, we can say, a particular set of question need to be practiced. Some question might be common, but some particular question you have to practice from individual examination perspective. So let's go with the first question on the screen. Okay, Ratmesh, I hope so this is clear. First question, very easy. This was asked in ISRO, one of the like 3-4 years back, right? A footstep bearing and a rotor of vertical turbine forms an example of. Very easy. Footstep bearing and rotor of a vertical turbine forms an example of incompletely constrained motion, partially constrained motion, completely constrained motion, or successfully constrained motion. This type of question, while revision also, I have told you many number of times, please make sure you are practicing these kind of questions. Okay, tell me what is the answer for this, A, B, C or D? If you try to visualize, this particular member is going to have a rotational as well as a translatory motion, right? So definitely this is not a constraint. But if I want to make it constraint, can we say if I try to apply a force on this side, then we can remove this or restrict this translatory motion, only rotation will be there. So this kind of we can say example that is coming under the concept of option D. Very good, Deepak. Successfully constrained motion. Okay, because we are applying some external factor. Okay, we are applying this force F, then only we are able to eliminate this translatory motion, only rotation motion is there. So 1 degree of freedom. So this is an example of a successfully, because successfully we have completed, we have converted this into a constrained motion. Clear? Very good. Next question. Done? I don't think so you'll be having a doubt in these kind of questions. So let's go to the next one. For an epicyclic gear train, the input torque is 100 Newton meter. The RPM of input gear is 1000 clockwise, while that of the output gear is 500 RPM anti-clockwise. What is the magnitude of holding torque for the gear train? So I hope so you know about in epicyclic gear train there are three important members, right? We are having an input member, we are having an output member, and we are having an arm. Okay, fine, right? And normally we are, if I talk about this particular gear train, we are fixing the arm. Fine. So they're asking you what should be the torque that you need to apply to hold that arm. What is the holding torque? Quickly do it. What is the holding torque? I'm only asking the magnitude. Might will be getting a negative value, right? That only tells you about the opposite to the direction as of the input torque. Okay, if you are getting a negative sign, that simply means if input torque is giving an clockwise sense, then the holding torque will be an anti-clockwise sense. Quickly, A, B, C or D? Option A, option B, option C or option D? For an epicyclic gear train, the input torque is given. Now, whenever you're having these kind of question, first of all, you have to apply the this one. The total torque for the system will be 0. The total torque acting on the system will be 0. That means we're having input torque, we are having the fixing torque, plus we are having the output torque equal to 0. Okay, and also we can say the net power is also equal to 0, or we can write input Ni plus fixing torque Nf plus output N0 equal to 0. Now fixing torque, definitely it is already fixed, so this is basically 0. There is no rotation to the arm, because it is, we are talking about holding torque, we are not having any RPM. We are having input torque, input RPM plus output torque, output RPM equal to 0. What is the input torque? 100. What's the input RPM? 100,000 clockwise. Okay, output torque we can calculate. What is the output RPM? 50. That is anti-clockwise, will be having a negative sign. Okay, so from here, can you tell me what is the output torque? Quickly, what is the output torque? Output torque will be 100 into 1000 divided by 50, because this negative sign when you go to the right side will be positive. So this would be simply 2000 Newton meter. Okay, now we got the value of TO, we know the value of TI. Can we get the value of fixing torque or holding torque quickly? A, B, C or D? Option C. Very good, Deepak. Okay, so input plus fixing plus output is equal to 0. Input torque is 100, fixing torque we need to calculate, output torque is 2000. Okay, so from here the fixing or holding torque is minus 2100 Newton meter. If I want to calculate only the magnitude, that will be 2100 Newton meter. Okay, 2100 Newton meter. This is the holding or fixing torque. Option C is the correct answer. 2100 Newton meter is the final correct answer. Done? Clear? Understood? Any doubt in this? If no doubt, let's go to the next one. This kind of question, they are very frequent as for velocity and acceleration analysis. If you take out any ISRO paper, every alternate time they are gonna ask you at least one question from this topic. Okay, so let us try to see. OABC is a 4-bar mechanism. Some distance given OA, AB, BC. Fixed link OC is 3.5. OA rotates at 10 radian per second. So this value is given as 10 radian per second. Right? 10 radian per second. PO is given, PC is given, extended to meet at point P. Okay, this is point P. What is the radial acceleration of B with respect to C? What is the, okay, tell me, can you tell me how many type of accelerations we are having? What are the different type of acceleration that we are having? One is quickly tangential and second is radial. Okay, if I say tangential acceleration, that is equal to r into alpha. Radial acceleration is r omega square, right? Fine. Now they're asking what is the radial acceleration of B with respect to C. That means if I say this is, I'm taking this as link 1, this is link 2, this is link 3 and this is link number 4. So let us suppose this is omega 4. Okay, so we can say the radial acceleration will be simply equal to the length BC into omega 4 square. Length BC into, so if I'm able to calculate the value of omega 4, because BC length is already given, you can easily get the value of radial acceleration. So tell me how to calculate. How to calculate the radial acceleration of this member B with respect to C, that means BC member. And the radial acceleration direction is always toward the center, so it will be from B to C. Quick, option A, B, C or D. I hope you are able to see this red color. There is no problem in seeing. If I want, I can change the color to yellow. Okay, what is the answer for this? They are given the value of omega 2. See, omega 2 is equal to 10 radian per second. This is given in the question. Okay, now let us try to write the I centers. So this will be I12, this will be I23, this will be I34, this will be I14, and I think this will be I13. Okay, so we got the position of I centers. Okay, these are the I centers whose position we know. Okay, now if I want to calculate omega 4, omega 2 is given, so we'll be having combination of 2, 4. So for that you should be knowing the I24, which we don't know, right? So definitely won't be going in that approach. But if I manage to calculate omega 3, then I will be able to easily calculate the value of omega 4. I've given you a hint. Calculate the value of omega 3. From there you can easily get the value of omega 4, right? Quick. Omega 2, I12, I23, omega 3, I13, I23. Okay, omega 2 value is how much? Omega 2 is 10. 1 2 2 3, 1 2 2 3, that means AO is 2. Omega 3 we need to calculate 1323, 1323, this distance. See, this total distance is P2O. P2O distance is 6 centimeter. Okay, this is 2 centimeter, so this will be 4 centimeter. P2A, so this is 4 centimeter. So what is the value of omega 3 you will be getting? Omega 3 will be equal to 5 radian per second, right? Now apply the same logic between 3 and 4. So we can write omega 4 I14 I34 is equal to omega 3 I13 I34, right? Omega 4 we need to calculate I1434, 1 4 and 3 4, that means BC is 2.5. Omega 3 is 5. 1334, 1334 means this one, okay. BC is 2.5, this distance is 2.5. This total distance is from P to C. P to C is 6.5. And what will be the distance? That will be 4. This will be 4 centimeter. Okay, fine. So now we can calculate 1 3 and 3 4, that will be 4. So what is the value of omega 4? What is the value of omega 4? So 5 into 4 by 2.5 is 25 into 10, right? So we'll be getting 258 radian per second, right? So now we got the value of omega 4. We know the length of BC, that is 2.5. BC is equal to 2.5 centimeter. Can you tell me the value of radial acceleration, that is BC into omega 4 square? So BC is 2.5 into 8 square. Answer is, quickly, answer will be 2.5 into 8. 2.5 into 8, 40. Please check, 40 centimeter per second square. 40 answer, 40 centimeter per second square. Option A is a correct answer. Clear? Fine. Option A is a final correct answer. Done. Okay. Fine. You have to think, because questions are not at all difficult. Remember one thing. Any examination, that could be ISRO, GATE, the question level is not that difficult. For the past few years, the level of examination is slightly on the conceptual side. So if your concept is strong, whatever difficult question they're gonna frame, no problem, you'll be happily able to solve it. Okay, fine. Chalo, next question. In old times coupling, the maximum velocity of sliding is 0.25. So V max is given as 0.25 meter per second. Driving shaft N value is 180 RPM. Then what is the distance between the two parallel shafts? A, B, C or D? What will be the distance between two parallel shafts? Quickly. Simple question. You know Vmax? Vmax is nothing but omega into the distance between the shaft, right? So omega value, this is given 0.25. Omega is 2 pi n by 60 into d. So d will be equal to, this is 3. So 0.25 by 6 pi. Okay. This will be meter. So this will be 250 mm by 6 pi. Approximately, what could be the answer? Approximately, what could be the possible answer? See the option. All options are not that close, so easily will be able to answer it. 41 by 3. 41 by 3.14. So we'll be getting 41 means 3, 12. 12.12 or 13. 13 point something. Please check. We're getting somewhere around 13.56 mm. 13.26 basically, not 56. 13.26 mm. Done. Okay. 13.26 mm is the final correct answer. All right. Next question. Any doubt till this point? All clear, right? Next question. Let's go to the next one. In case of a 4-link mechanism, A, B, C, D, A, B, B, C, C, D, and D, A, some length is given, C, D is fixed. Which of the following mechanism will be obtained? So let me draw this A, B, C, D. A, B, C, and D. So this is A, B, C, D. They are fixing CD link. This is being fixed. AB is how much? 3 centimeter. BC is 4 centimeter. This is 8 centimeter. This is 6 centimeter. So this is the shortest link, right? This is the longest link. This is P and this is Q. So S plus L is equal to 3 plus 8, 11 centimeter. P plus Q, 4 plus 6, 10 centimeter. So is the Grashof law satisfied or it is being violated? Is it satisfied or not satisfied? Grashof. Grashof's law, is it satisfied or not satisfied? What is Grashof law? S plus L must be less than or equal to P plus Q, right? Right? Fine. As it is greater than, so it is not satisfied. It is not satisfied. If Grashof law is not satisfied, you fix any link, you will always be getting what? Double rocker mechanism. Okay, double rocker mechanism, option B. Even though you can clearly see that the shortest link is on the coupler side. Okay, the shortest link is on the coupler side. So by default, even if it is following, it is being satisfied, no worries, it will still be getting a double rocker mechanism. Okay, it will still be having a double rocker mechanism. Done. Option B is the correct answer for this question. Double rocker mechanism. Okay, next one. The eye center of a sphere undergoing a pure rolling on a curved surface. So let us suppose this is a curved surface and there's a roller rolling on this curved surface, right? Then where will be the eye center? Where will be the eye center? There is a pure rolling on the curved surface. Quickly, this is an easy one. Many times this question is being asked in multiple examination. The eye center of a sphere undergoing pure rolling on a curved surface lies at infinity, at the center of the sphere, at the center of the curved surface, at the point of contact between sphere and the surface. Quickly, tell me the answer. Not that difficult. Not that difficult. Quickly. Now we know that if we are having a roller, okay, rolling, definitely the eye center will always be at the point of contact. Even if it's a flat surface or a curved surface, it doesn't matter. So we can simply say that at the point of contact of the sphere or the surface, we'll be having the eye center. Okay, this will be the eye center for a pure rolling on the curved surface. Done. Okay, Dheeraj is also in the comment section, so definitely entire team is now available for you guys for this ISRO exam, right? Okay, next one. PQRS is a 4-bar mechanism as shown below. PQ length and RS length is given. PS is fixed. Omega PQ is given as 5 radian per second. Then what is the velocity at this point? What is the velocity of this point? Quickly. It is basically parallel. Okay, it is basically a parallel to this input and output link are parallel to each other. So simple question, what will be the velocity at point R? What will be the velocity of at point R? Linear velocity. Okay, now remember one thing. If you have revised, you might have known if input and output link in a 4-bar mechanism is exactly parallel to each other and perpendicular to the base, so definitely at that particular instant, the coupler link will always form or follow a pure translatory motion. So what is the velocity at point R? Same velocity will be there at point Q. VQ will be equal to VR. Why? Because your coupler link is undergoing a pure translatory motion. Now we know the value of omega PQ, we know the value of distance, so we can simply say VQ will be equal to R into omega or PQ into omega. So this is 300 into 5, that is 1500 mm per second, or we can, this is 1.5 meter per second. Answer for this is option B. No need to calculate omega of RS, then calculate your RS into omega of RS. Not required, because we know the concept. This way only you will be able to save the time. This one more way, you will be calculating the value of omega of this, then putting the value VR is equal to omega of RS into the distance RS. Not required. Okay, not required. We try to simplify the solution as simple as possible to save the time, because in PSU examination time is very crucial. Time is very, very important. Okay, fine, understood, done. Next question on the screen. Very easy. The favorite question for engineering service. Many times they have asked, according to Kennedy's theorem, the three eye centers of three-link mechanism having relative motion between the links lie on a triangle, a parabola, a circle, or a straight line. A triangle, a parabola, a circle, or a straight line. Any three eye centers of a link which is having a relative motion between them, they always try to form in a straight line. They always try to form in a straight line. Okay, fine. Option D is correct answer. Done. Okay, next one. Ninth question. Very easy. Two gears are in mesh having constant velocity ratio 3 and module is 2 mm. What is the circular pitch of the gear? Circular pitch. What is the formula of circular pitch? PC is equal to pi into d by t or pi into m. Okay, so answer is 2 pi. 2 pi mm. Clear? Right? Circular pitch is nothing but pi into m. M is nothing but d by t. But in the question, they have given you directly the value of module. You can use that, get the answer. Right? And they're asking in mm only. So we'll be getting answer as 2 pi. Okay, done. Next question, 10th one. The module of gear 1 having number of teeth is 5 mm is meshing with the second gear having 20 number of teeth. What's the distance between the mating gears? What is the distance between the two gears? The first gear is having number of teeth is equal to 10. Second gear is having number of teeth 20, and definitely the module will be same because they are meshing. That given as 5 mm. So what is the central distance between the two gears? Direct formula based question. Tell me the answer. Direct formula based question. A, B, C or D? Quickly. Option A, option B, option C or option D? Yes, Deepak, Prasant, Pratmesh. A, B, C or D? Simple. We do a simple formula. C is equal to your m by 2 t1 plus t2. That's it. right? M by 2, because M is equal to D by T, so from there we can get the value. Okay, option D, very good. So 5 by 2, very good Deepak, very good Ram. 10 plus 20, 30, 30 by 2, 15 into 5, 75 mm. 75 mm, option D. Clear? Done, very easy. Next one, 11th one. Okay, now question from some vibration topic. Question of natural vibration. They have given a equation, what's the natural frequency. Very easy problem. Again, a very easy question. What's the governing equation for natural vibration? For natural vibration, the governing equation is x double dot plus omega n square x equal to 0. Get the value of omega n and tell me the value. There's a possibility of small mistake that you can do, but I hope so you are not doing that mistake. Quickly. 3 hertz, 1.75 hertz, 2.5 hertz, or 3.5 pi hertz. So if I try to compare, omega n square will be equal to 49 by 4, or omega n will be equal to 7 by 2, or we can say 3.5 radian per second. Okay, 3.5 radian per second. Right? So definitely that is not the answer. They're asking in hertz. We know that 2 pi f is equal to omega n. So f is equal to omega n by 2 pi. We'll be getting so pi is also there, na? Pi square. So pi is also there. 3.5 pi. Okay, we'll be getting 3.5 pi by 2 pi. So that will be 1.75 hertz. Option B. Very good. Very good, Ram. And done. There is always a possibility of making error by calculating omega and marking option D wrong, because they are asking the hertz. They're asking the natural frequency in hertz, not in radian per second. If the question would have been radian per second, then option D would have been the correct answer. Okay, done. So next one. They've given the damped equation. They're asking you the damped frequency. Again, an easy one. Compare with the general equation. The general equation is x double dot plus 2 zeta omega n x dot plus omega n square x equal to 0. So try to compare this equation with the main equation and tell me what is the value of omega d, the damped frequency of vibration in radian per second. Damped frequency of vibration in radian per second. Quickly. Option C. Option Sandeep is saying option C. Anyone else? Deepak, Ram. Option A, B, C, or D. Easy question. C is not a difficult one. First of all, compare the equation. Option D. Very good, Deepak. D is correct. D is the correct answer. Because if you try to compare, so omega n square is equal to 25, or omega n will be equal to 5 radian per second. But they are asking omega d. So omega d is nothing but root of 1 minus zeta square into omega n, right? So compare this thing, we'll be having 2 zeta omega n is equal to 8, because this equation must be compared with the main equation, this one. Okay, fine. So zeta will be equal to 8 by 2 into 5, 4 by 5. So 4 by 5 is nothing but 0.8. So we got the value of zeta is equal to 0.8. If zeta equal to 0.8, we'll be getting somewhere around here, root of 1 minus 0.8 square into 5. So this is root of 0.36 into 5. So this is 0.6 into 5, that is 3 radian per second, option D. 3 radian per second, option D. Okay, done. This kind of mistakes we need to avoid, and it is quite obvious. We know that the damped vibration, the damped frequency will always be less than that of omega n. Damped frequency will always be less than omega n, right? Okay, fine, understood, Sandeep? Clear? Okay, so these were some set of questions for today's session. So I mean, again, I'm repeating, we have already launched an Udaan course, which is basically the practice session, only practice for the upcoming ISRO 2025, right? So we'll be having a live sessions, practice live session, where we'll be having, I think 150 plus, or 100 plus of hours. Okay, but in short, we'll be having 150 plus only. Okay, so make sure you are enrolling to this course only for practice. But the students, those who are not confident with the revision, so there's another course we have launched. We are having a revision as well as practice, so we can revise and then practice. Okay, so it's only dedicated for ISRO, a dedicated course for ISRO paper. Okay, fine. So please do follow us and do try to download our app, and our app, your Resultant mechanical app, where you will be getting these two set of courses. Clear? Done? Fine. So that's it from my side. I hope you all enjoyed this session, and the next session will be by Vikas sir 2 days after. Okay, that means today is Wednesday, so we'll be having on Friday. We'll be coming live with you guys, the fluid mechanics on Friday, and he will be giving you the more number of questions for practice on our YouTube channel. And those who are new to the channel, please make sure you are subscribing so that you'll be getting the latest update. Okay, so we are having two courses for ISRO, the practice course as well as the revision plus practice. Try to opt whichever is suitable for you, and if you see, the fees is very, very nominal. Okay, in the entire market, you'll be getting a very nominal fees for this ISRO, only dedicated for mechanical engineering. Okay, so thank you guys for staying connected with us, and let's meet in the next upcoming session for ISRO. So our target must be ISRO. Don't worry, you'll be having YouTube sessions also, right? And if you want to solve more set of questions, for that only we have launched this Udaan course. Okay, so thank you guys. Bye bye, take care, stay safe, and enjoy your preparations with Resultant. Thank you.